All right, so the first thing to know is that we have positive angles and we also have negative angles when we are doing angles that are on a coordinate plane. We start out like this. Our angles that go in a counterclockwise motion, so that means like against the way the clock goes, these are our positive angles. So if our angles start here and open up this way, this is a positive angle. Okay. And if we're going the other way, if we start there, this is always our starting line when we're talking about angles, and we are going the other way, there'll always be an arrow to indicate which way your angle is going. This is a negative angle. So if our angle is going in a counterclockwise, it's positive, and clockwise is negative. In a way that I remember that as I think about the quadrants, think about how you number your quadrants. All right, isn't it 1, 2, 3, and 4? Aren't these our 4 quadrants? So if I'm starting here, which I always start on the positive x-axis, and if I'm going counterclockwise, my numbers are going up, 1, 2, 3, 4. So that would be a positive angle. If I'm going the other way, my numbers are going down, 4, 3, 2, 1, and that would be our negative angle. So if we're going in the way that our quadrants are increasing, that's a positive, and decreasing, that's a negative. Okay, that's why the quadrants are named that way, because of angles. If you ever wondered why it was just weird to start that way. Have you ever thought, like, why is it 1, 2, 3, 4 when that makes really no sense with anything else you've ever done? Yeah, that's why they're named that way. Okay, so that's a positive angle versus a negative angle, which is important for us to know. The next thing we're going to look at is how we measure angles and how they can be actually defined. We have 2 ways that we can do that. And the first way, and the way that you've done the most often, is a degree. And if someone said to you, define how big 1 degree is, or tell me how big 1 degree is, how could you tell them specifically how big a degree is? Anybody have an idea? When you think of degrees, what do you think of? Are there any shapes? Yeah, what shapes? A triangle or a circle? A circle is the one we're going to use for this. So how many degrees are in a circle? 360, right? Yeah, there's 360 degrees in a circle. So for us to tell someone specifically 1 degree is 1/360th of a circle. Hey, Jalea, we just started, but these will be recorded, so you can go back and watch like the first 2 or 3 minutes. Okay, I'll post them after we do our lesson today, so you can see that, and I'll post the notes too. But you just missed like the title, really.
Okay, thank you.
Positive and negative angles. You're welcome. All right, so a degree is 1/360th of a circle. So if you have a circle and you can equally cut it into 360 parts, then you'll know what 1 specific degree is. Would that be really easy, just to make it into 360 equal parts by yourself, like freehanding it? No, it wouldn't. That would be hard. Our second way that we can measure angles, these are called radians. What a radian is, this is kind of interesting to think of. So our radian, 1 radian is the same like measure of degree for each of it. But if you're going to do it, I'm going to show you a picture. What is this length from the center of the circle to the outside of the circle called?
Radius.
That's the radius, right? So 1 radian is if you took the same length of the radius, we'll call it r. If you took that exact same length and put it on the outside of the circle, so it's like I measured this radius and I wanted this exact same size. So I'm going to put that exact same size. I'm kind of estimating here. This is also r. These two are the same lengths. The angle measure that you get is 1 radian. So if you have the length of your radius on the exterior of your circle, the angle measure that is made from that is called 1 radian. So that's what a radian is. How many radians do you think are in 1 circle? Guessing like we got a 4, got a 2. Any other guesses? Got a 5. So let's think about it. So this looks kind of like it's close to like a third of, your half here. So I'm just rough sketching. So I'm doing this. I'm going to do that same R again. So here's another one. Here's another one. And then here's another. What are we thinking now? Any guesses now? I'm guessing around 5, 6 of them. Okay. Do another. I kind of did that one a little bit small. So I've got 6 plus a little bit. So there's 6 of these radians, and then we have just like part of one. Okay. So what it actually turns out to be, like technically in every single circle has 2 pi radians. So to go all the way around the circle, you have 2 pi number of these r's. Is that kind of like 6 and a little bit? Because how have we always measured pi? When we measure pi in distance, we measure that as what? What's the number for pi?
3.14.
3.14. So 2 times 3.14. I forgot the 1. That is 6.28. Okay. So pi comes from a circle. It doesn't come from like a 3.14 or whatever. They were trying to measure how much is around one circle, and that's where pi stems from. If you wondered why we have this random decimal number for that. Okay. So to go all the way around is 2 pi radians. So 2 pi radians matches up with 360 degrees. And so from that, we can figure out how to switch back and forth between degrees and radians. Okay. If all the way around the circle is 2 pi, what is halfway around the circle?
Pi.
1 pi. So that's important for us to realize as well. So you might want to have a visual of that. That this all the way around, we start here. We're going all the way around the circle. That's going to be 2 pi. If we're going halfway around the circle, that's 1 pi. So what about if we're going to go a quarter of the way around the circle? How much is that going to be? Yeah, half of pi. And the way that we write half of pi is just pi over 2.
Miss Roselle, for the first circle, what was the circles again? I know you said 2 pi, but
2 pi, it goes all the way around it.
Okay, thank you.
Okay, yeah, it starts at the beginning and then it matches up where it began. So all the way around is 2 pi, halfway around is a single pi, and a quarter of the way is pi over 2. Okay, and underneath we can put what degrees match with this, and this is going to start for us to figure out how to go back and forth between degrees and radians. So all the way around the circle is how many degrees? 360. Halfway around the circle is how many degrees?
180.
180, right? And a quarter of the way, this is what kind of an angle? 90-degree angle, right? So if you see pi, that can be replaced with 180 degrees, okay? 2 pi is the same as 360, and pi over 2 is the same as 90. So in this unit, we're going to be going back and forth between those. So sometimes your answers will be in pi's, sometimes they'll be in degrees, and you've just got to know how to switch those back and forth. So I'm going to show you a quick way for us to convert them. Do you guys do unit conversions like in chemistry if you're switching between, I don't know what y'all measure, liters and milliliters or something, and you have to make like a conversion fraction thing that you use and you multiply it across and stuff has to cancel? Yeah, that's the same thing with switching between radians and degrees. Okay, so I always think about the fact that pi, I like to do the single pi just because there's not any other number with it, is the same as 180 degrees. And I'm going to use that fraction. That's what I'll multiply by just to determine what I'm going to use. Okay, so if I was going to go from radians to degrees, so I want to go from radians to degrees. I want to get rid of the radians. I want to change it into degrees. I'll multiply my fraction, my radian measure, multiply by. If I'm getting rid of radians, do they need to be on the top or the bottom? If you're getting rid of something. This is how y'all learn those conversion things. Do you remember that? You want to get rid of it, it needs to be on the bottom so it'll cancel. Okay, so if I'm getting rid of radians, they need to be on the bottom. Degrees needs to be on the top. So if you're going from radians to degrees, you're going to multiply by 180 over pi. And if you don't want to do a conversion factor on that, you can always plug 180 degrees in where you see pi. So pi and 180 are the same thing. So whenever you see a pi and you want to change it to degrees, you could always just put 180 in. It's the same thing as doing this conversion factor. And from degrees to radians, I want to get rid of the degrees and I want to change them to radians. So if I'm getting rid of the degrees, where do they need to be? If you're getting rid of something, it needs to be on the bottom, right? So we're going to multiply by pi over 180. And there's not just a simple thing for you to plug in on that one. Okay. So we're going to do a couple of these. So we're going to switch from radians to degrees and also degrees to radians. So we'll start out with radians to degrees. If I had pi over 10, I know that's in radians because there's not a degree sign. And it has a pi in the problem. That's a good indicator. So I want to take this and switch it into degrees. So I'm going to multiply by 180 over pi, or I could just plug in 180 for pi, but we'll see what this is. I'm going to multiply by 180 over pi, and I'm timesing these together. So what's going to happen to my pi's? They're going to cancel. That's why we put it on the bottom, so that they would get rid of each other. And I have 180 over 10, which is 18 degrees. Okay. I'll show you that, how you can do this one a little bit quicker by just plugging 180 in for pi if you would rather do that. So pi over 10, we said that pi is the same thing as 180 degrees. So I can just replace the pi with 180. And that gives you 18. Okay. So when you replace it, it essentially does the canceling out for you. Okay, any questions on switching from radians to degrees? We multiply by that, cancel where we can. Okay. Going from degrees to radians, it's not quite as, you have to make a fraction. So some people get a little bit confused, but I normally just use my fraction tool in the calculator. It's not really, once you think about that. Okay. And the trick is to not actually put pi in the calculator, because you want to leave your answer in fraction form. So if I wanted to do 60 degrees, I want to change that into radians. Okay, so for me to change it into radians, the radians need to be on the top, because that's what I want to keep. I don't want the degrees anymore, so that needs to be on the bottom. I'm going to multiply by this. So you think about the degree symbols actually canceling out. Here we had pi canceling out. This one, the degree symbols are going to go away. So this is what I want y'all to do with this. Don't actually change pi into 3.14. We're just going to write 60 pi over 180. And then we simplify the numbers in the front. So if you can do that in your head, that's great. If you need to use your calculator, that's okay. So just do 60 divided by 180. That's a third, right? 1/3. So this is going to be 1 pi over 3, which is the same thing as just pi over 3. So once we write it, we simplify this fraction in the front. Then we write it that way. Okay. Does that make sense? So don't actually put pi into the calculator. You're just going to take whatever number you have, basically divide it by 180, simplify, and the pi is just going to stick there. Sometimes it's like 2 pi over 5 or 3 pi over something else. Okay. The ones that we use all the time, just so you know what they are, these are like the most basic angle measures, just for you to have them. So we do 30 degrees all the time, 45 degrees a bunch, 60 degrees, 90 degrees, 180, and 360. And we'll write their radian measure next to it, just so you don't have to look those up all the time. Eventually you'll say, oh, okay, I got that. And some of these we've already done. So what's which one do y'all want to just go ahead and tell me what the radians are? Any of them that we have? Somebody can just raise their hand or unmute themselves and answer. So we're just doing the radians next to it, what it would be with the pi's. What was 360? 360 is how many pi? All the way around the circle is 2 pi. Good. Once round the circle is, not once round, halfway around the circle is 1 pi. That's our 180 degrees. 90 degrees was a quarter, which was pi over 2. We did 60 degrees just now, and that was pi over 3. Okay, 180 divided by 3 makes 60. Okay. 45, that's half of 90. So if you cut a half in half, you get a fourth, right? So that's pi over 4. And 30 degrees is going to be pi divided by what? 180 divided by what gives you 30? 6. Good. And you can go back and check all of these, but 180 over 6 is 30. 180 divided by 4 is 45. 180 divided by 3 is 60. 180 divided by 2 is 90. 180 is 180, and 2 times 180 is 360. So now we have two things that we plug in for pi sometimes. So if you're talking about like distance or ways you go around the circle, like actually measuring something, that's when we use 3.14. When we're talking about going back and forth between radians and degrees, the pi in our head becomes 180 degrees. Okay, so sometimes you have to think about the difference between those. Okay. I will talk about standard position, coterminal angles, and then we have two formulas to do. They're really quick, and then you guys can start working. Standard position of an angle, this is kind of like what I was leading to at the beginning, where we would be on the X and Y axis. When an angle is in standard position, that means the one that we use the most. We start on the x-axis, and then we're either going positive direction or negative direction from there. So this one's a positive one. Your initial side is always on the x-axis. The other side that's floating out in space somewhere or in your coordinate plane, that's your terminal side. This is called initial side. It's where you start. This one is your terminal side, where you stop. Initial, and it goes up to the terminal side. So just like before at the beginning, if it's going counterclockwise, this is a positive angle. If it's going the other way, that would be a negative angle. So this one's positive if it were going the other direction, and that's going to be told to you by this little arrow in here that's telling you which way it's going. That would be negative. Okay. All right. There are ways for us to represent the same initial and terminal side, but have different angle measures. And for us to do that, that's called coterminal angles. Co means share, right? That prefix means that it's going to share, or with, where they share the same terminal side and the same initial side, but they have a different angle measure. So that's called a coterminal angle, and we'll be finding some of those. So they share the initial, they share the terminal, but they have different angle measures. Y'all are going to help me out with that in a second. We're going to see if we can figure out how to do that. So we're going to write down just a few different ways for us to represent this, just letting you know from here to here is 145 degrees, not 145, 135 degrees. So that's 135 degrees. That's one way to represent something that has this initial side and this terminal side. So that's one way that we can name this angle. And we're just sticking to degrees with this one. We'll do one in radians in a minute. What's another way that we could Name this 135-degree angle, or this same thing that's got this initial and this terminal. Is there another number that would still give us this same side, beginning side and ending side? Anybody think they know? What's another way that we could do that, but it's going to be a different number?
Is it gonna have to do with pi?
No, we're going to keep it in degrees, but
Okay.
we'll be able to switch it back and forth in this. These are just going to be how we can use the same two sides, but have different numbers. So this one we went in the positive direction. Could we maybe go
In the
other way?
opposite direction, and you got to find the other.
You got to find the other part, right? So we could go in the opposite direction. We still start here and finish there.
45.
How could we figure out what that was going to be?
We subtract 135 from 180
160.
or one
circles.
or 360.
From 360?
Yeah.
To get all the way. And so what would that be?
$125.
Close.
225.
Yeah, 225. You had the 25 right. So it would be 225, but it's not going to be positive 225. It's going to be negative 225 because we're going backwards. So negative 225 degrees. So that's another way that we could represent it. Okay. Do you guys ever watch the X Games when they have the snowboarders and they're going up on the half pipe and stuff? Do they stop at one rotation when they're doing their spins and tricks? Can they keep going around the circle, or can they keep spinning? So sometimes we stop at 360, but we could also keep going. What's after 360? What's the next rotation? Do you ever hear it? They're like, oh, they did a 720, or they did a 1080, or they did a whatever comes after that. That's going around the circle more than one time. So we're not limited by stopping once we've gone once around the circle. We can go more than one time around the circle. Okay, so we're going to have the same beginning and ending, but for this next one that we're going to do, we're going to loop all the way around the circle first. So I'm going to do this one in red. It's going to be kind of messy. So I'm going to start here, going all the way around the circle, and then I'm going to stop at that point. So I've gone all the way around the circle once, and then I go 135 degrees to end at that same specific point. So how could we figure out what that angle measure is?
Is it 360 plus 135?
Yeah, it's going to be 360 because we went around 360, and then we add 135 to that. So 135 plus 360 gives us 495 degrees. Okay, so if you're asked to find coterminal angles, you can either add 360 to your number, right? Because that's going to be going in the clockwise direction, or you can, or counterclockwise, or you could subtract 360 from your number and get that. So to get your coterminal angles, they'll sometimes ask for one positive one and one negative one. You're going to add 360, and then you could also subtract 360. Sometimes you might want to add a couple times, a couple 360s, or subtract a couple ones. So we're going to add and subtract 360 degrees. So 135 minus 360 is negative 225. 135 plus 360 is 495. Because you'll occasionally be asked to find, like, what's the cosine of 540, and we don't have that just on our regular 0 through 360 graph, so you're going to have to subtract to be able to get it to where it's something that you're used to seeing. So that's why this is important. Okay, so that's if it's in degrees. What would it be if it was in radians? We're not going to add and subtract 360, but we're going to add and subtract radians is what for 360 degrees? All the way around the circle is 2 pi. So that takes a little fractioning. So I'm going to show you one of those just so you can be familiar with how to do it. So let's say I wanted to find coterminal angles, two of them, a positive and a negative, and my original was 2 pi over 3. Some people don't like to do this with fractions. They just instead would rather switch that to degrees and do it and then change it back, which is okay. I don't care. But if you wanted to stick with radians the whole time, we're going to subtract 2 pi and we're also going to add 2 pi. So we have to do two things. We're going to do both of these problems. Do these two numbers here have the same denominator for us to be able to add them together? No. Our denominator is 3, though, that we're looking at, so they both need to match and have a denominator of 3. All right, since that one doesn't have one, remember we would do 3 on top and bottom. So it would be 2 pi over 3 plus 6 pi over 3. And same thing on the bottom, 2 pi over 3 minus 6 pi over 3. Does everybody agree that 6 pi over 3 is the same thing as 2 pi? Because what's 6 divided by 3? That is just 2. Okay, so now we can do that. 2 pi and 6 pi makes how many pi? 8 pi. And 2 minus 6 is negative 4.
Can you show us the other way?
Yeah, the other way is if I would switch this to degrees first. I know that pi is the same as 180. So 2 times 180 is 360, right? And 360 divided by 3 is 120. So I would just be doing 120 degrees plus 360, 120 minus 360, which this is 480 and 240, negative 240. And then I would change those into radians. So then you would put like 480 times pi over 180 and negative 240. And simplify it that way. Which is 8 pi over 3 and negative 4 pi over 3. So it just takes a couple more steps of changing it back and forth. So for coterminal, you add 360 and subtract 360 if you're in degrees. Add 180, subtract 180 if you are, add 2 pi, subtract 2 pi if you are in radians. The next two things are just formulas that I'm going to show you. These are things that show up all the time on the ACT, and I don't know if you've just never gotten to them or what. I always just kind of figure them out logically if I see them when I'm working ACT problems, but there is a specific formula that you can use, okay? If you were asked for the arc length, what do you think they're asking you to find? The length of the arc. which is just a specific section of the exterior of a circle. So the arc length, if I had a circle, like this, my arc length for this specific problem is going to be, what is this distance right here? Okay. And we label our part.
How would you know? I'm sorry. How would you know if it wasn't the other side?
They're going to label it. They'll have like it shaded in here or this angle measured. They'll specify which one it is. Yeah, it would be like this. They'll have it like that, drawn that way. Okay, and we call this angle theta. Have y'all seen theta before for an angle? Okay. We have the radius r. And the arc length, what letter do you think we use for arc length? A? Yeah, we would think we would use A, but it's an S. I don't know why. So S is the measure of the arc. R is the radius. And the theta is there. Okay, that's the angle that you have from initial to terminal side, which corresponds with our arc length. If your angle is in radians, this is really easy to do because of the way that we talk about circumference of a circle. Like, what is the circumference of a circle all the way around it? Do you remember the formula? Circumference is 2 pi r, right? 2 pi is all the way around the circle. R is the length of the radius. Remember, there are 2 pi radians that go around the circle. So if you want to know how big the whole circle is on the outside, you just have to say 2 pi times whatever your radius is. And that's going to give you that. So that's where that formula comes from for this. So for us to figure it out, we just need to know how many radians we have times our radius. And that's going to give us what this specific arc length is. So our formula, arc length equals the radius times whatever our angle is, as long as our angle is in radians. So that is the arc length formula. So your angle has got to be in radians. If it's in degrees, you have to switch it first. So we always have to switch it to radians. So we know how to do that. Okay. And I remember this formula just because I always turn it into my first name. I go like this. I mean, y'all don't have the same first name as me, so it might not be as important or so memorable, but I just do this. And now it spells Sarah. And I remember it. But if your name is Nick, it's not going to work. I can't move the green anymore. Come on, green. Move. So I'll show you how to do one if they give it to you in radians, and then we'll do one if they give it to you in degrees. There's just the one extra step of switching it into radians. Blessings, was that your sister?
Nah, that's my
Your
mother.
mom?
Mm.
Well, you can tell her I said that.
Okay.
But she looks like a student that I used to have whose last name was Jones. And I was like, I didn't know they were sisters. But okay. All right. So if I've got a radius of 2, an angle measure of pi over 3, and I want to find this arc length, I'll use my formula. S equals radius times the angle. Our radius is 2. Our angle is pi over 3. So our arc length is 2 pi over 3. And you can put that if they want you to give it to you in a decimal form, just in the calculator, 2 pi divided by 3. And that is 2.09, whatever units you're in. Okay. So that formula, pretty basic, radius times the angle measure, if it's in radians. But when you're taking the ACT, almost all of the time they give you angle measures that are in degrees because they kind of want to make it more equitable for students that haven't had Precal or Trig yet. So let's look at one of those and see how we could easily switch it into radians or how you could figure it out otherwise. What do you guys want your radius to be? You can give me a number. 4, okay. And what angle measure do we want? How far around? $120? Somebody say that? Yeah, 120. No, what? 115? 100 in a million? 115. Okay. So let's see. This is 120. This is 90, right? So I only need to go like 15 more. No, I don't. 25 more. 15. Sure. Let's say that's 115. 115 degrees. And we're trying to figure out this much right here. Okay, I'm going to show you guys how to use radians for this, and then I'm going to show you how I would actually do this on the ACT because I probably wouldn't remember to switch it to radians and use this formula. Okay, so we need to make this into radians first before we can just say 4 times the angle measure. So the first thing we need to do is we need to switch 115. I want to switch it to radians, so my pi needs to be on top and my 180 needs to be on bottom. So I went like this, 115 pi over 180. I simplified that fraction in my calculator and it gave me 23 over 36. So 23 pi over 36. You actually don't need to simplify it if you don't want to. You could use it unsimplified. It's going to be fine. So that's what it is in radians. Now I can use my formula. S equals R theta. R is 4. Theta is 23 pi over 26. And you put that in the calculator and you get 8.03. Or you could go ahead and rewrite, what would that be? 4 simplify, that's a 36, not 26. 23 pi over 9 is what it would simplify to. Yeah. All right, do you guys want to see how I do these problems without having to do anything with radians? Just to think about it? Okay. Every time I see these on the ACT, I always think like, okay, I don't remember the formula for arc length, but I know the formula for circumference, right? Your formula for circumference is 2 pi r, and 2 pi r is all the way around the circle. But I don't want to go all the way around the circle. How many degrees do I want to go around the circle? 115. So I think about it as a percentage. It's 115 out of how many degrees? 360. So every time that I do this, just in my, not in my head, but if I'm working them out, I figure out the whole thing, which is 2 pi r. So that would be 2 times pi times 4. That's all the way around the circle. And then I say, I only want this percentage. So I will multiply it by 115 over 360. Does that kind of make sense? If you were having to do it without radians or for those. Like if I wanted half the circle, I would do the whole thing times a half. If I wanted a fourth of the circle, the whole thing times a fourth. But this is just what part of the circle that I'm looking at. So if you wanted to do it without radians, you could as well. I mean, you do have to have radians in the pi right there. So you do this whole circle times what part you're looking at. Okay. And last thing, this is similar to the same thing. You're using part of that as well. But this is the area of a circular sector. It's not just the arc length. It's all the shaded in area in one of those sections. And our formula is 1/2 r squared theta. Okay. What would it be if you went all the way around the circle? How many pi is all the way around the circle? 2, right? 2 pi. So if I plugged this in, if I plug 2 pi in for this, go ahead and cut it in half. What's 2 pi if you cut it in half? How many pi is that? 1 pi. And you would just have pi r squared. Do you recognize pi r squared?
Yes.
Yes, that's the area of a circle, and that comes from the same formula here. So all of this stems from things that you've already done. We're just going to do part of it. So the part of it would be there, but you have to have the cut in half because of the 2 pi part. So same thing, this theta has got to be in radians. But you just plug in the information as we did before. So we can use the same numbers that we did up top if you want to. What did we have? 2 and pi over 3. But instead of arc length, we want to know the shaded area. The shaded area in here. They'll always shade it to let you know that you're actually doing the area inside. You just plug it in the formula. R is 2. And that equals 4 divided by 2, which is 2, pi over 3, and you can put that in the calculator if you want a decimal value, if you need one. Sometimes you'll need exact. So same thing, it just has to be in radians, so if they give it to you in degrees, you have to switch it first.